is that we are going to look at specifically what qualifies as a function and what doesn't qualify as a function. And this is the hardest piece for students to grasp. And until we grasp this idea, right, nothing else really fits. So the umbrella topic today is relations. Relations is any set of ordered pairs, any type of comparison of two things. Okay, it could be your height to your weight, or it could be the number of cookies you ate yesterday to your favorite color. It doesn't have to be numerical values. It doesn't have to necessarily be something that makes sense to go together. Okay, they are the large bucket. Okay, this large bucket of relations has properties that we've probably been seen or been introduced to in the past. Okay, so those types of things that we have been introduced to or have seen in the past are different ways that we can represent those ordered pairs. Different ways we can represent that information. Okay. Put it on my desk.
I'm not on my phone.
What are you on?
Nothing, actually.
Put it on my desk. Set of ordered pairs. Okay. Set of ordered pairs is our probably most common way that we see something. An ordered pair, hopefully we know this, is always something that is represented with an x comma y. That information can then be taken and also written in a table. So this is one of my favorites. How many of you, when you see this thing, call it something other than a table? Where's my T-chart, people? Okay,
it's a table.
This is a table.
A T-chart doesn't have size.
Yeah, because it has
Yeah,
size.
a T-chart is just a table. It is a table.
But you know,
Technically, a table is like this.
Okay.
technically, it can still be a
It is a table.
This is a table.
When we create a table, we are just taking our ordered pairs and we are putting them into our table where our x value is sitting next to its coordinating y value. Right?
Wait.
When we represent this information, hopefully we say, yep, I've seen this before, these are both familiar. When we represent our information in either of those ways, we should be able to go in either direction. So if I give you ordered pairs, you should be able to go, oh yeah, I could write that as a table. If I give you a table, you should be able to say, oh yeah, I could look at this and I could pull out an ordered pair and that would be 3, 7. That seem familiar? Sound familiar? Can I get a thumbs up, thumbs down? We say so I can at least get a response. Are we alive?
Yeah.
Yes.
We're alive. Okay.
It's Friday.
A mapping is one that you should have seen before, but we don't work with it as often, so my students tend to forget this one. Okay, a mapping is where we're representing information kind of in two bubbles. It doesn't have to be a bubble, but okay, where we have our x values over here on the left and our y values over here on the right. Mappings get much more specific rules. When we are listing a mapping, our x values and our y values have to be in numeric order. What does that mean? Least to greatest. Okay, and we cannot list any repeats. How many of us say, I think I remember that too? Yeah, that number tends to drop a little bit. As we sort of talk about it, my students start going, yeah, I think I kind of sort of remember that information. Okay, so if we are given the ordered pairs, I'm just pulling the top one, which is going to create the same table, so you don't need to write this down. I just want you to follow along. 1, 2, 3, 7, turn this into a mapping. Okay, this first oval is going to be all of our x values. So where are x values in ordered pairs? The first one, right? So I'm taking all of these, and I'm going to put them in numeric order. Right, so they're numerical from least to greatest. So I have -4, 1, and then 3.
Yes.
Okay, and then in this bubble, I'm going to do all the y values. Where does the y value come in an ordered pair?
Behind.
The second one, right? So that in order, 2, 6, 7.
Yes.
And then it's kind of like connect the dots, like match the pairs.
Yes.
1 goes to 2, so I'm making a line from 1 to 2. 3 goes to 7, so I'm making a line from 3 to 7. -4 goes to 6. Again, this is another option where if we were given this information, we should be able to turn that into ordered pairs. So we should be able to look at this mapping and say, oh yeah, this is the ordered pair 1, 2, and I could turn that ordered pair into a table. So far, so good? Okay, option 4 is that we should be able to plot these points on the coordinate plane. The coordinate plane is a really funny standard. It's like you do a lot with it and actually talking about the coordinate plane in like younger years, and then you just kind of start like graphing and everybody just assumes you remember some of these things and it's been a little bit. So we want to make sure we have a few reminders here. The coordinate plane has 4 sections to it. Do you remember what these 4 sections are called?
Quadrants.
Quadrants. Do you remember how we number those 4
It
sections?
goes 1, 2, 3, 4.
It goes backwards with Roman numerals.
Yeah.
So 1, 2, I mean everything about it is backwards.
That
My
doesn't
students are
make
like,
any
why are we
sense.
going counterclockwise and why are we using Roman numerals? I blame old dead men. I don't know. They made it up. I didn't. Okay, and when we plot a point on the coordinate plane, like 1, 2, right? It's always x, y. And which one of our axes is our x-axis? The horizontal, right? This is our x and this is our y. So if we want to plot the point 1, 2, we go 1, 2, and we make a point. And hopefully we're like, oh my gosh, Ms. McKinney, yes, I know how to do this. Okay, and then we can plot the point 3, 7. Then we can plot a point -4, 6. We're not connecting the dots. We're not drawing anything else in there. All we have is 3 ordered pairs, so we're plotting 3 points. Okay, you will get points on your test that you can like plot points on a coordinate plane, that you can tell me what the x value is of an ordered pair, that you can create a mapping. Those should be points that are handed to you, that if you took the test today, you would already get all of those points.
Yes.
This is why I'm saying the test isn't all that difficult. It's really up there with an easy one. Now, here's then probably some new vocabulary, or at least vocabulary that you haven't thought about for a while. When we are talking about relations, there are 2 words that we will hear come up a lot, and that is the domain and the range. Any of us say we remember those words, or we've heard those words from the past? What is the domain? That's also what I thought, right? I definitely heard it, but I don't remember anything about it. The domain is the same thing as saying we're going to talk about the x values. But the domain gets some very specific rules. So here's where we have to be a little bit careful. When we are talking about the domain, we need to make sure we list it in a very specific way. And you're going to be like, this is so dumb. Why do we have these rules? The rules will make sense later. Just not right now in this unit. Okay, when we're listing the domain, we're going to list the x values in numerical order with no repeats, and it needs to go in braces. And the student's like, ugh, I have to draw one of those things. Well, yes, you do. Can I just put a parenthesis instead? No, you cannot. Now, could your brace look terrible and just sort of kind of look like a squiggle? Great. Okay, but we need it to be in braces. In the math world, when we put things in braces, that is denoting that it's a set that belongs together. Okay, is our set notation. It means something very specific, so we need it to be inside braces. Okay, so if domain is the range or the x values, what do we think range is going to be? The y values, and it gets all of the exact same rules. So the range, we are going to list the y values in numerical order. I mean, you could just put like same as above and not write all this stuff down again if you would prefer. No repeats in braces. Okay, so there will be 6 points on your test that you can just list a domain and range. Those should now be getting handed to you. So if we want to list the domain from the example above, well, domain is the x values. So what was our x values in this example? Okay, so 1, 3, and -4, but what do we have to do with those numbers? Rearrange them to numerical order. So -4, 1, and 3. And what do we have to put that inside of? Braces. I have made probably 5 billion braces in my life, which is why I can draw them probably better than a lot of you, which is fine. Okay, the range is the y values. So what were our y values?
2, 6, 7.
Right, 2, 7, and 6, and we're rearranging those into numerical order, and so we're going to say 2, 6, and 7, and we're going to put those in braces. I mean, that doesn't require brain surgery, right? That just requires you to know a basic definition. Those are points that should be handed to you. So then let's look at this next example. So if we want to list the domain for example 2, domain is which values? The x values. So if we're listing our x values, there are our x values. Can I list them in any order that I want?
No.
No, I need to go in numerical order. So what's my smallest number?
-3.
-3. What am I going to list next?
2.
Why am I not listing -3 again?
Can't repeat.
No repeats. So it only counts one time. So -3, 2, and 7. Our y values. What are we going to list for our y values?
5, 6.
5, 6, and 9. No repeats and numerical order. Those should also be points that are handed to us on the test. Okay, knowing this information, does this help us breathe a little bit easier about the fact that we'll have a test next week, maybe?
Yes.
Kind of. Now, here is the deal with listing domain and range. You just have to make sure you know those pieces of no repeats in numerical order and in braces. Because like you'll get a point that you list them in numerical order. And you'll get a point that you list them in braces. Right? Domain and range are the one unique situation where we can't go back to the other forms. If I'm given these ordered pairs, I can turn them into the domain and range. But if I'm only given the domain and range, I cannot turn that back into ordered pairs. Okay, it's our one that doesn't allow us to go between the different forms. It tells us other important information, but it doesn't allow us to move in between all the forms. Any questions on this info? Hopefully, like, yeah, this is all a review. I pretty much heard this. Okay, then flip your paper over. This is where we have to think a little bit more. And most of this actually is probably also review. Did this flip to right? can't get that to do it on its own. The bigger piece here is not understanding what these different pieces are. It's actually getting the big picture, which means our umbrella topic, our large bucket, was relations. Okay, we want to narrow in our view. We know this information about relations. We want to narrow our view to focus on functions. A function is a relation. So we're not talking about something new. We're talking about something that is more detailed. A function is a relation. Okay, so if I say go to the store and buy milk, what type of milk might you purchase?
White.
Skim.
Skim milk,
Chocolate.
chocolate milk, 2% milk, almond milk, vanilla milk, whole milk, bleh, whatever, right? All these different things that you could purchase that are milk.
Goat milk.
Goat milk.
Okay? There are all these different types of milk you can purchase.
Soy milk.
You cannot, though, say, if I say go to the store and buy 2% milk, you're not buying chocolate milk.
Well, you can buy 2% chocolate.
Yeah, okay. Buy 2% white milk. Okay, this is sort of the category we're in. Relations are all of those different types of milk. Functions have some special stuff like chocolate added to it, and it's chocolate milk. Okay, so a function is always a relation. Chocolate milk is always milk. Okay, but relations are only sometimes a function. For a relation to qualify as a function, each element of the domain is going to have to be paired with exactly one element